I'm Herendeen, energy researcher from the old days, and a fellow economist. What I'm talking about today is the connection between net energy and prices of energy and other goods. We know that we're trying to get energy harder to get in places. We expect that to increase prices, which has all kinds of policy implications. There are at least two avenues to get it. One is to go down the left side of that slide, more or less standard economics. Cadre of energy researchers prefer the right-hand side, which goes through net energy analysis, which compares energy you get from an energy activity compared with the energy that needs to go into it in the form of energy itself and all the other inputs. Following from that is something called the net energy ratio. That's also called EROI, but I'm going to try to call it net energy ratio. If that is large, meaning a lot of energy out for a little in, that's good. If that approaches 1, which means you have to put as much in as you get out, that's bad. You should keep that in mind as we move on. I have built an input-output based model to try to track both energy and prices. Input-output economics has all kinds of interactions between components of an economy which are attractive from that standpoint, and I exploit that. It gives the dollar price of energy and other goods as a function of net energy ratio, and that's good, but net energy ratio depends on 4 relations in an I/O table, and so does price, and they depend in different ways. What that means is that EROI, net energy ratio, is not uniquely determined, and therefore there's ambiguity in the results you get. Let me try to illustrate that. If I just blindly go ahead and do my calculation, I find that price, as a function of net energy ratio, behaves the way energy people would like to think. As that ratio gets smaller and approaches 1, the price goes infinite. No surprise. If you want something, you're willing to pay for it, and there's no more of it around, you're willing to pay a lot for it. So that's nothing new, and that's to be expected. However, if you account for this ambiguity I mentioned and put some uncertainty into the system, it looks this way, in which there's a lot of fuzz on those relationships. I should point out that in this diagram on the right-hand side, that's where we are right now. The United States has a net energy ratio suitably defined of about 29. So it's far from 1, and therefore, as we move down from that, let's say down to 20, not a lot happens, especially when you account for all the uncertainty in the system. So what I've concluded, and it's no surprise, is that net energy is an imperfect method for getting at prices. Doesn't mean we shouldn't have a shot at it, but I'm not sure it's really fruitful in the long run. Thank you.